Hi, welcome to Engage New York, Module 4, Lesson 32. 32, we're at Lesson 32 out of 33 lessons in this module. So read the objective while I read it aloud. I can interpret and evaluate numerical expressions, including the language of scaling and fraction division. All right, just as a reminder, scaling and fraction, addition, subtraction, multiplication, and division are probably the biggest standards, the biggest objectives that we are focusing on in fifth grade. Scaling, like 2 times bigger, 3 times bigger, 1/2 the size is scaling. So those have been the ideas that we have been focusing on in Module 4 and for quite some time, for 32 lessons by the way. So interpret and evaluate. So I can read something and make sense of it, and then I can do something with it. And in what we're going to be doing today, we're going to be working with scaling, and we're going to be working with fraction division. All right, let's get started. We're going to begin, and this fluency activity prepares you for today's lesson. So we're going to start with Pemdas. Do you remember what Pemdas means? Pemdas means parentheses, exponents, multiplication, division, addition, subtraction, right? All right. So what do you remember about Pemdas? Number 1, the problems always are solved from left to right if there are no parentheses. The equation is solved from left to right unless there are parentheses. If there are parentheses, you always do what's in the parentheses first. Other than that, you go along the PEMDAS little acronym to help you know what operation you should do next. Now, when it comes to multiplication and division, it doesn't matter. They're both equal. But if multiplication comes first, you do multiplication. If division comes before multiplication, you do the division. If, for instance, so in this problem right here, division comes before addition. So you're always going to do division before addition. But if there is multiplication or division in a problem, in the same problem, you're going to move from left to right and solve that problem across and going from left to right. Because when they're in the same problem and there are no parentheses, multiplication and division can be equal in their order. So let's go ahead and start. What is 12 divide 3? 12 divided 3 is 4, right? 4 plus 1 is 5. Now, what if we had added parentheses here, though? So we would have 12 divide the quantity of 3 plus 1. Well, parentheses come first, so you would have had to do 3 plus 1 first, and that would give you 4, and then you go 12 divide 4 is 3. So notice, if you don't solve something in the correct order, you're not going to get the right answer. So you have to follow the rules of PEMDAS in order to get your problems right. So we have no parentheses. We have no exponents. Do we have multiplication? No. Do we have division? Yes. So 24 divided 6 is 4 minus 2, which is equal to 2. Then right here, we have 20 minus 4 divide 2, right? Now, what is 20 minus 4 divide 2? What should we do first? Do we have parentheses? No. Do we have exponents? No. Do we have multiplication? No. Do we have division? Yes. So we're going to solve 4 divide 2 first. We're going to go 20, subtract 4 divide 2 is 2, which is 18. Then we have here, let's go 16 plus 4 divide 4. Now, do we have parentheses? No. Do we have exponents? No. Do we have multiplication? No. Do we have division? Yes. So we're going to go 4 divide 4 is 1. 16 plus 1 is 17. All right. Now, all of this would have changed if we had simply added in parentheses. If we would have done 20 minus 4 is 16. 16 divided by 2 would be 8. So just going back, just as a memory, just to prepare you for today's lesson, we're just starting off with that. Next, this is a review of lesson 29. So how many tenths are in 1? There are 10 tenths, right? So how many tenths are in 10? 100, right? How many tenths are in 20? 200 tenths, right? Then let's go over. Now remember, the secret here, it's really like multiplying, right, by 10. So 43 times 10 is 430. Remember, when you're dividing, it's really like multiplying by 10 because it's tenths, because you have to multiply by the reciprocal, right? Remember, 435 and 0.04 times 10 still gives us 0.4. All right, just a quick little review. Do you remember? Whenever you're dividing by point tenths, hundreds, or 1,000, it's really like multiplying by the reciprocal of that. Okay, now let's go as a quick review to dividing decimals. Now, we worked on this on our last lesson, lesson 29 and lesson 30. Can you solve these division problems? All right, so let's just start off. 8 divided 2 is what? 4. What am I going to multiply by in order to get rid of this decimal? Times 10, times 10. 8 over 2 is 4, right? All right, what about this one? What are you going to multiply by? You're going to multiply by 100, right? To rename that decimal as a whole number. And this, you're going to move ones twice. You're going to end up with 80 over 2, which is 40. Remember all this? Okay, we're going to do this side together, then you're going to do this side and come back and check your work. So what are we going to do here? Multiply by 100, multiply by 100, then we get 8 over 2, which is 4. All right, with that quick little review, now I want you to take on these 4 problems, come back and check your work. All right, did you get 4, 4, 40, 40? Do you see the way I multiplied, got rid of my decimal, and turned it into a fraction? And a fraction is really a division problem as well. All right, now continue our review. Now we're going to go and we're going to do the same thing we just did, but now we're going to use the division algorithm. If you have to just make a mess all over the place to try to fit it in, just make a mess. Come back and check your work. Okay, yes, my paper is a hot mess. All right, but just to go to show you that yes, I am doing the work. So your answer for this problem here is 14.15 or 14 and 15 hundredths. Over here you get 318. Down here you get 820. And here you get 92. So yes, I did do all the work just to show you, yes, it pays off to do the work because you end up with the right answer. Yes. All right, the last part of our fluency for this lesson is 4 baby socks can be made from 1/3 of a skein of yarn. You know that those things of yarn that you see at those little bundles of yarn you might see at the craft store. Those are called a skein, and they're soft, and they're wrapped, and the yarn is like looped like this all together. That's called a skein of yarn. How many baby socks can be made from a whole skein? So out of a skein, how many baby socks can be made? So before we start, let's just draw a tape diagram and think this out. Okay. So 4 baby socks can be made from 1/3. Okay, so we know we have to cut this into 1/3. And we get 4 baby socks out of 1/3 of a skein, right? So how many baby socks can be made from a whole skein? So what I want you to do is go ahead and figure out the rest. How many baby socks can be made from a whole skein of yarn? I don't think it's going to be that hard. I think you probably have all the information you need right here just to solve the problem. All right, so just based on this, it's 4 divided into thirds, right? So 4 times 3 is 12, or I could say 1 unit is equal to 4. So I'm going to multiply that by 3. So if I multiply by 3 over here, I multiply by 3 over here. 3 units is equal to 12. 12 baby socks can be made. 12 baby socks can be made from 1 skein of yarn. Now that's the answer. All right, that'll do it for our fluency for lesson 32 in module 4. We'll be back here for concept development.